Right, let's look at simultaneous equations. Simultaneous equations are, we generally just follow a set of instructions that we were given and we never understand what we're doing. So let's look at example 1. The question says solve for x and y simultaneously in the following equations. What does that mean? That means find the x value and the y value so that when you go 2x minus 5y, the answer gives you minus 12. And simultaneously, that means at the same time, if you use that same x value and that same y value and you went 4 times x plus 5 times y, you would get 6. So basically, I'm looking for the one x and y value that work in both of these equations. That's what I'm looking for. Now, our approach is generally a recipe, and I'll try and explain as we go along why it works. But generally, I pick the easiest equation to work with, and I pick an equation where I can isolate one of the letters. Now, neither of these equations are particularly nice because if I chose this equation, and I'm going to label him equation 1, and I'm going to label this guy equation 2, if I pick equation number 1, I need to isolate one of those letters. Now, if I isolate x, as in I make x the subject, I'm going to have to divide by 2, which means 5y divided by 2 is going to give me a fraction. But if I look at equation number 2, if I'm going to try and isolate x, I'm going to have to divide by 4, which is going to give me a fraction. But I'm afraid either of these are going to give me fractions when I isolate a letter. So I've just got to pick one of them. So I'm going to pick equation number 1. Equation number 1 says 2 times x minus 5 times y equals minus 12. Now I'm going to isolate either the y or the x. Now I'm going to choose the x. So I'm going to say, right, 2x would be plus 5y to both sides. So 5 minus 12. And I'm going to divide each term by 2. So I get 5 over 2y, and minus 12 divided by 2 is minus 6. Now that means that this x value, according to this equation, is equal to 5 over 2y minus 6. I'm going to call that equation 3. Now, because we're looking for the x value that works in both, we're talking about the same x value that works in both. So this x value here is the x value that will work in that equation as well. It's the same x value. So what we do is once we've isolated a letter, we go and substitute it into the other equation. So I'm going to substitute my equation number 3 into equation number 2 because the x that works in equation 1 has to also be the same x that works in equation 2. So instead of writing x, I'm going to write 5 over 2y minus 6 because that's what x is equal to, and it's the same x in both equations. So for x plus 5y must equal 6. Now the reason why this works is I now have an equation with only one unknown, so I can solve for that unknown. In this case it's y. But this whole logic is because the x in equation 1, if you get it by itself, that has to be the same x as equation 2. So I can put it in place of that x, this expression, because I'm solving for the same x. Now if I multiply my 4 in, 4 times, now you can use your calculator if you don't like multiplying fractions, but 5 over 2 is 2.5, and 4 times 2.5 is 10y, and 4 times minus 6 is minus 24, plus 5y equals 6. Now, this is a simple linear equation, so I get 15y. I'm going to plus 24 to both sides, and then I can divide by 15 to get 2. Divide by 15 on both sides. So that's the y value that will work in both of these equations. Don't forget to find the x value. The question is solve for x and y simultaneously. Well, fortunately, I can go back and put y is equal to 2 in this equation or in this equation, and it'll work out the same x value because I'm finding the same x and y that work in both. Or it might be easier to just go put y is equal to 2 in equation 3, because equation 3 already has x by itself. So there's 3 different options here. I'm going to use equation 2 because equation 2 said x was equation 3 said x was 5 over 2 times y, which is 2, minus 6. So x must be 2 goes into itself once, so 5 minus 6 is minus 1. Now what does this mean? This means if you use x is equal to minus 1 and y is equal to 2, those x and y values will work in both of these equations. Now, let me quickly check for you. 2 times minus 1 minus 5 times 2. What does that equal? Well, 2 times minus 1 is minus 2. Minus 5 times 2 is minus 10. And doesn't minus 2 minus 10 give you minus 12? So x is equal to negative 1 and y is equal to 2 works in equation 1. Let's check equation 2. 4 times negative 1 plus 5 times 2. What does that equal? That equals negative 4 plus 10, which equals 6. So this one set of x and y values works in both equations, which is what solving simultaneously is about. Now, there was an easier way to solve this particular equation, so I'm going to raise this and show you quite a nifty way to solve simultaneous equations, but unfortunately it only is very useful in certain equations. So let me show you what I mean. When I look at these equations, I notice a minus 5 and a plus 5. Now I know if I add minus 5 and plus 5, they'll disappear. Now with an equation, you can add an equation to another equation, or you can subtract an equation from one equation. So I can add 2x minus 5, I can add the one side of this equation, and to minus 12 I can add 6. Now let me show you why this is useful. 2x plus 4x would give me 6x, and minus 5y plus 5y would disappear, which means immediately I only have one variable in this equation. Minus 12 plus 6 is minus 6. So immediately I can divide by 6 and tell you x is minus 1. And then I can go substitute into one of those equations and solve for y. Now, some of you might have no idea what I've just done, and this way of solving simultaneous equations suits some people and it doesn't suit other people. And it doesn't always work easily. So I decided I'd show you one example like that, but other than this example, I'm going to do every simultaneous equation by doing the normal process. So I'm going to look at the next example and just do what I would normally do in any simultaneous equation. So if you didn't like the short method, rather listen here. So simultaneous equations. A good method is to label equation number 1 and equation number 2. I'm looking for an x and a y value that work in both of these. My steps are label 1 and 2. Next one, pick the easiest equation where you can isolate one letter. Now, if I look at equation 1, there's y all by itself, and I can easily get rid of minus 2x. So for me, I think my easiest equation is equation 1. So from equation 1, I can tell you that y minus 2x equals minus 1. So if I isolate y, I add 2x to both sides, and I'm going to call this equation 3. So steps are pick the easiest equation and isolate one of the letters by itself. Now this y is exactly the same y as they're talking about equation 2, because that's what simultaneous equation means. It's the same y value. So I am going to sub my equation number 3 into equation number 2. So 5x is negative y, and instead of writing y, I'm going to write 2x minus 1, because equation number 3 tells me that y is the same thing as 2x minus 1. And the reason why that's very useful is, have a look. I now have an equation with only one unknown, which means I can solve for it. So I'm multiplied my minus 1 in. I'm going to add 2x to both sides, so I get 7x. Plus 1 plus 2 is 3. I'm going to divide by 7 on both sides, and I get 3 over 7. So that is the x value that will work in both of these equations. The question is what y value corresponds to that x value. Now again, you can go put this x in there, you can go put the x in there, but the easiest thing would be use equation number 3, because equation number 3 says y is equal to 2x minus 1. Well, that means that y is 2 times 3 over 7 subtract 1. So this means I can do y is equal to 2 times 3 over 7. Use your calculator if you don't like this. That's 6 over 7 minus 1. And again, use your calculator if you don't like it. That's negative 1/7. That means that x is 3/7 and y is equal to 1/7 will work in both of these equations. And if you had time in an exam, I would go and substitute x and y into both of those and check that they worked out. I'm going to quickly check the first one. So y, we've just said, is negative 1/7. Yep. So does negative 1/7 minus 2 times 3/7? The question is, does that equal minus 1? Well, use your calculator. Let's quickly check. That's negative 1/7 minus 6/7, which if I use my calculator is minus 1. So they definitely work in that equation. I would then put them into this equation and check that the left-hand side equals the right-hand side. And then in an exam, you know that that's your 6 or 7 marks. Right, now I would pause this video, I would take down each of these examples and try to solve for x and y simultaneously. Do your best to check your answers, and if your answers don't work in the equations, go back and watch one of the questions I did again, and then try and follow the same technique. Good luck!